In this video, we're going to look at example 5 from section 4.2, where we graph a rational function. So the question, what is the graph of f of x equals 4x squared minus 9 over the quantity x squared plus 2x minus 15? So for these, you're going to want to find vertical and horizontal asymptotes first to kind of give you an idea of where the graph kind of follows along. And then from there, you'll be able to pick some x values, plug them into a chart, and find your y values. What I'm going to recommend on these type of problems is you write the factored version of whatever rational function you have here. So we have 4x squared minus 9 and x squared plus 2x minus 15. I want to write the factored form of both the numerator and denominator. And like I said, just factor anything that you can. Sometimes you'll be able to factor it, sometimes you won't, but it will always make your life easier if it's factored. My numerator, 4x squared minus 9, I see that's the difference of two squares. 4x squared is a perfect square and 9 is a perfect square. So this is going to be 2x plus 3 and 2x minus 3. Now x squared plus 2x minus 15, I would need a factor sum chart. I'm just going to do this quickly because this is not a video on factoring. I would need factors of negative 15 that added up to a positive 2. I'm going to, again, go through this quickly, and my factors would be negative 3 and 5. So I'd have x minus 3 and x plus 5 would be the factored form of my denominator. Having that gives us a good idea of if any of these terms wind up canceling out, and I'll explain what that means and why that matters as we go through the graph, or go through the problem, sorry. All right, so from here, let's determine, now that we have the original form and the factored form, let's determine if there are any vertical asymptotes. If there are any vertical. Asymptotes. All right. So to do that, remember, we want to know when the function is undefined, when the denominator would be equal to 0. So we're going to take our denominator of x minus 3 times x plus 5 and set that equal to 0. The zero product property then tells me I can take each one of these expressions and set them equal to 0 and solve for x. So x would be equal to 3 and x would be equal to negative 5. So these two are possible vertical asymptotes. And the reason I say that they're possible ones is that there is the chance that they're not actually asymptotes and they're just holes in the graph. They are vertical asymptotes if they can't be canceled out in your original function. All right. If I look at the factored form, let's just pretend there was another x plus 5 up here. If these canceled out, that tells me that this x equals negative 5 would not be a vertical asymptote. But clearly, that's not there, so we don't really have to worry about that. But that's kind of what you want to be aware of. And that's why I suggest you factor both the numerator and the denominator. Because if one of those expressions was able to be canceled out, then again, it's no longer an asymptote, it's just a hole in the graph. Neither one of these can be canceled, so they are vertical asymptotes, okay? So let's label that. After we've checked to confirm, our vertical asymptotes are x equals 3 and x equals negative 5. Okay. After we've determined if there are any vertical asymptotes, now we want to determine if there are any horizontal asymptotes. So next step, we would determine if there are any horizontal this time. And to do that, we need to compare the leading degrees. So this is where we don't care about the factored form. We want to go back to this original f of x equals 4x squared minus 9 expression. All right. You don't want to look at the degrees of the factored form. You want to look at the degrees of the original form. So here I have a degree of 2 and a degree of 2 in the numerator and denominator. They're the same. If you remember from earlier in the lesson, that's case 3. I'll go all the way back. That's case 3 where the degree of the numerator is the same as the degree of the denominator. And what that tells us is that the horizontal asymptote is the ratio of the leading coefficient. Okay, so we want to keep that in mind. It's going to be the ratio of the leading coefficients. So let's go back to our problem. And if I look at the leading coefficients, those are, let's highlight these in pink. That's 4, and in this case there would be a 1 there. So the horizontal asymptote would be, remember horizontal goes left to right, that means it goes through the y-axis, so that would be y equals, it would be 4 over 1. Or obviously we can just reduce that, and that would just be equal to 4. All right, so highlighting, I want to keep track of all this. So horizontal asymptotes, there we go. And then vertical asymptotes, those are those two. Okay, so from there, we want to plot or sketch our vertical asymptotes, vertical and horizontal asymptotes onto the graph. So the vertical ones are going to be 3 and -5. Do be careful in this case. Our jumps are by 8. So just because I'm sketching this, I'm trying to make this fairly accurate. So we're going to have a vertical asymptote somewhere here. We're going to say that's our -5 one. We're going to say that this is our -3. They're definitely not the most accurate ones I've ever done, but it'll do. And then our horizontal asymptote would be, what do we say, 4? So that's going to be right about here. Okay, that one's a little bit easier because it's directly between 0 and 8. Okay, so we now have our vertical and horizontal asymptotes sketched, and we then, oh, we made a mistake here. It was -5 and +3, so let's fix this. Apologize for that. That actually makes our lives easier because we don't have to cram a graph in there. All right, so that other vertical one is going to be at 3, not at -3. Apologies. So vertical asymptotes at 3 and -5. That makes a lot more sense. That is much better, and you'll see why. All right, the next part of this is now we need a chart. We need points to plot. The easiest way to do that is to take your function and type it into a graphing calculator. The handwritten way to do that is to create an XY chart and pick some numbers. Now, we have 3 sections. We're going to need numbers on the left of the asymptotes, in between the asymptotes, and to the right of those asymptotes. So what I'm going to recommend is you pick numbers like, I'm going to go left, so I'm going to do -24. Well, I'm not actually going to work these out. -16 and -8. That covers your left side. Then in the middle, I would probably pick, maybe something like -2, 0, and 2. That might give us a good idea of what that graph looks like. Yeah, and we might have to pick other numbers if we're doing this by hand. And then on the right side, I would probably choose 8, 16, and 24. This is where doing this by hand becomes a nightmare. All right, because in theory, I mean, if you're doing this by hand, you've got to take -24 and plug it into your function and simplify that. And then you've got to do the same thing with -16 and -8 and -2 and all the way through. We don't really want to do that. Use a graphing calculator, use a program like Desmos, and just find the charts and find the points, and you can use those to kind of mimic your sketches there. Again, I'm not going to spend the next 20 minutes on this video figuring out what all of those are. I'm just going to draw the sketch because I know what the sketch looks like. So this left side is somewhere in that realm. Again, it's a sketch, it's not going to be perfect. This middle section kind of, again, has to fall between these asymptotes, right? So we're looking at something that's kind of like this. All right, might not be perfect, but it's close. And then there is something slightly a little bit unique on this right section. You wouldn't know this looking just at the graph or the eye, but what's going to happen is this does technically cross the asymptote a little bit, and then it comes back up. So once you get greater than 3, which this doesn't perfectly show, the x values are going to get larger, right? As we move to the right, greater than 3. But it actually drops below that asymptote, right, that horizontal asymptote of 4, and then it approaches it from below. So it's tough to really show this without completely zooming in or showing on a graph that's been, like a Desmos program. But this part of the graph here is just going to come back up towards the asymptote, and it's just going to track along it, but it's never actually going to cross over that. All right, so it's just something to keep in mind. Unless you're specifically looking for it, you wouldn't really know that, especially if you didn't plot specific points. So just keep that in mind. All right, it's noted in the book. It's just there, but it's fine. For these problems, my recommendation is always to factor first. Factor both numerator and denominator. That way you'll know whether the possible vertical asymptotes are actually asymptotes. Remember, if they cancel out, they're just holes in the graph. They're not actually an asymptote. After you have the vertical ones, the horizontal ones are usually much easier to find. And then from there, use some kind of application to fill in your XY chart and get plots that you can point to draw your graph. That's it. These aren't the most fun, but I do think you'll be fine working on them.